Hi and welcome back. This is Gaffy's Grinds and this is video 4 in our series on atoms, elements and the periodic table. If this is if you're jumping in for the first time, then you should go and watch the previous 3 videos before you jump in here. Otherwise, you may not understand some of this stuff. If you're returning and you know the rules by now, eliminate any distractions you might have by closing any open tabs on your computer or your phone and turning off your social media. Just again, trying to eliminate any distractions. It's really important that you do any questions and tasks when I give them to you. It's going to be really important. If you don't do them, you're not going to learn very much at all. In this topic, we're going to be talking about what we call atomic structure. So we're going to be taking a closer look at atoms than we have before. And it's really important to note that the work of some really amazing scientists have gone into this. Not just one or two, but like countless, hundreds of scientists have contributed to building up our understanding of the atom and how, what its structure is, how it's made, what makes it up, and all the other different things that we actually know about it. Some great scientists like Einstein, Schrodinger, uh, Newton you've got some really important scientists who have contributed to this, but there are many, many more as well. And the more you stay around and study chemistry into leaving cert and into university, you get to hear a lot more of the cool stories about those people's experiments and how they actually found out and discovered what they did. And why are we so reliant on these people is because, like I said, you can't actually see an atom. It's not like a physical part of someone's body or an animal's body where you can get a hold of one and you can study it like a heart or lungs, for example, where you can actually get from an animal a heart or lungs, study them, see how they work, see the parts. You can actually see and touch and feel them. With an atom, you can't do that. So you're relying on some brilliant experiments and some brilliant experimental work by scientists to then figure out a model of the atom. So when we talk about the atom, we're really only ever talking about models of the atom because no one's ever actually 100% sure. We just use the best evidence we can to put together a picture so that we can understand the atom. And that's what we're going to be doing, is discussing with you a model for the atom. Another thing that's really important to know is that as you go through school and college and you study more about the atom, you do more chemistry, you start to figure out that actually the model is always getting more complicated. We know a lot more about the atom than what I'm going to tell you today because it's important that we start at the basics and with a simple model like we're going to do today. And as you go through your education, the more you study about the atom, the more you're going to get added to it. So uh, it's really important that if this is the only chemistry or only stuff you ever do about the atom, that you don't go around thinking that's it, that's the full story, and I know everything about the atom, because I don't know everything about the atom, and I don't think anybody does. So all we can do is work off the models that we have. So you're going to be getting a model today for what we think the structure of the atom is like. Now, I've previously given you a model, which was the most basic type of model, and it went something like this. So where we have let's go back to the top of the page here. Sorry. Where we have done this before, we have something like this. So we have a container, and inside the container, we've often drawn what we call a particle model for a solid, which is where we draw the particles the way they would be in a solid like this. So we would say that this is a particle model for a solid, and we know this because the particles are stuck together in neat rows. There's no space between them, they're all touching. And we would say that each one of these circles represents an atom, or that's what we might have said before this. So each of these circles represents an atom. So today we're going to make it a little bit more complicated. They're not just going to be blank circles anymore. And this is a model of an atom, but it's a very simple one. The first thing to know is that they are really small, and I mean really, really, really tiny. Even with our strongest microscopes, we still can't see them. And with it takes our most incredibly sophisticated technology to even figure out where these atoms are and what they're doing. So never mind be able to see them and look inside. But some experiments have given us some information about what's inside. Now, just how small are they? Well, if I was to say, here's a can of Coke, and we want to know, well, inside a can of Coke is obviously the liquid Coke. And we say, okay, in that amount of liquid, how many atoms are there? I'm going to give you a number here. I'm going to say 331. All right, you're going to say, well, that's not that many. They're not that small if there's only 331. What if I told you then that it's 331, but after there's 331, I have to add 22 zeros. So I have to add 22 zeros to get the number of atoms in a can of Coke. So that will give you an idea of just how small they are. If I could fit that many, so that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I need 10, I need the same again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 2 more. That's how many atoms there are in a can of Coke, roughly. Now, we have the word million for something with 6 zeros. We have the word billion for something with 9 zeros. We have the word trillion for something with 12 zeros. I don't even know how many atoms this is. I don't even know if we have a word for this. It's a massive, massive, massive amount of atoms, which shows how small they are. Another way of looking at it is if we take an atom of one of our biggest elements, uranium. Uranium is an element with some of the biggest, most heavy atoms. So if this is our heaviest atom or one of our heaviest atoms, how heavy is it? If I was to get one of them, how heavy is it? Well, if I was measuring like we normally measure things in kilograms, then I'm going to give you a number, 395. Well, one atom definitely isn't going to be 395 kilograms. That shouldn't seem right to you because that would be like, you know, the weight of a car nearly, okay? Or, you know, a small car. Definitely not that. So how big is it? Well, this time I need 26 zeros in front of it. I need to put 26 zeros in front of that number. So I'm not sure how many I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I need 7 more. 1, 2, 3, 4, 5, 6, 7. So 0 point, and that many zeros, 395. Okay, you don't need to know that number. You just need to get the appreciation that atoms are incredibly, incredibly tiny. Right, so with that, what is our model of the atom then? You're telling me how small they are, but what is the model? What do we understand at the moment? Well, what we understand at the moment is that atoms are made of smaller parts. Within atoms, there are 3 smaller parts. I'm going to draw them now. So I'm drawing some of the parts here in purple. These are going to be at the center of the atom. So in these purple parts, or what we call particles, are found in the center of the atom. And I'm going to say this atom has 3 of them. 3 purple parts. And it's got a second purple part that's joined with a second particle that I'm drawing in green that is also found in the center of the atom. I'm going to say there are 4 of these. So in the center of the atom, there are 3 purple particles and there are 4 green particles. They're all found right bang in the middle. There is another area that's outside the middle, and we draw them as circles. But really, these circles show what we call a circular path. So these parts outside the middle are moving around the middle in a circular path. I'm drawing them in red here. Okay, there are 2 of them here. And then in a part a bit further away from the middle, out here, there are more of these. So I'm just going to fix that. That's okay. We'll say there are 4 more. So there are 6 of these. Oh, no, sorry. No, I won't do 6. I'll do 4. Okay, so there are 2 in a part close to the middle, and there are 2 in a part far away from the middle, like that. Okay, so take a good look. What I'm going to do in a second is I'm going to get you to reproduce this diagram. Now, I don't, like as I usually say when you're watching these videos, don't be trying to copy down everything I say, just listen. And when I want you to do something, I will ask you. So you're going to need to get from me 3 different colors. So either color and pencils, or 3 different pens. And in a second, I'm going to hide what I've drawn there. And I want you to try and draw it from memory. So take a good look. And I'm just going to scroll down so you can't see it anymore. What I want you to do now in your copy is I want you to reproduce what I had in that diagram for me, please. So pause the video and reproduce that diagram. Okay, this is what you should have. All right, so you should only be watching, obviously, if you've done this. So you should have 2 different particles in the middle of the atom. You can draw them as small circles. And you've got to have two different particles, different color. Now I've drawn 3 of one and 4 of the other. Now it doesn't really matter which color you go for here, so long as you keep them separate. So one color and another color in the middle. And then in these circles outside, we draw them as circles. We're going to draw a third type of particle drawn in red. Now you can use a different color. Whatever colors you have is fine. All right. Now, great. Hopefully you have that. If you don't get it now, finish the rest, the bits you didn't have, fix it up. Okay, so you should only be watching now if you have that diagram complete. I'm about to tell you what the names of these particles are. Okay, I'm going to tell you what the names of the particles are. Now, like I said, I don't want you to write. I just want you to listen. Okay, I'm going to do the purple particles first. The purple particles here are shown by a purple dot. These are called protons. Protons. P-R-O-T-O-N-S. 1 proton, 2 protons. So these are called protons and are found in the middle of the atom. They are the purple particles. I'm going to draw the green ones now. The green particles are shown here. And those are called N-E-U, trons. Neutrons. We've got protons and we've got neutrons. They are found together in the middle of the atom. The red ones, these ones here, these are called electrons. Kind of like electricity, but electrons. They are related to electricity, which is why they have the name electrons. Now, again, I don't want to write anything, just listening. We call these 3 types of particles subatomic particles. Now, where do those words come from? Well, we've got ical, means small. And we've got part, which obviously means piece. So particles means small pieces. That's where that word comes from. And then the subatomic bit, well, what does that mean? Well, the atomic obviously refers to atom. And this important bit here is sub. Sub in this case means below or within. It's kind of like when you have a heading and a subheading. The heading is at the top of the page. The subheading is within the main heading, or it's below the main heading. Well, you've got an atom, and then you've got subatom, subatomic. So you've got atom, which is a particle, and then inside the atom, you've got smaller particles, so within the atom. All right. Now, what I've got here is I've got the amount of the diagram that you've done so far. See that there? I want you now to add the labels proton, neutron, electron. I want you to add those 3 particles, those 3 labels to your diagram. Pause the video and do it now. Okay, so you should only be watching the video if you have paused and you have done that now. Okay, so let's go back, and this is what you should have. Great. So this here is what you should have. Now we're going to add to this now. We're going to label some more different areas here. First of all, the label or the part in the middle where the neutrons and the protons are found. So this area in here where the neutrons and the protons are found, we call this area the nucleus. Now the reason we call it the nucleus means core. Okay, so it comes from a word that means core. So if you ever see the word nucleus, it means core. So this is the core of the atom. In the same way that the middle of an apple is called a core. So once you've eaten away all the flesh of the apple, the center is called a core. Well, the nucleus kind of means the same word. The nucleus means core or middle. So the nucleus is the part that contains the protons and the neutrons. We call this the nucleus. Each of these circles here is what we call a shell. is what we call a shell. So we call this circle here a shell. And shells are sometimes also called energy levels. Energy levels. And that's got to do with how much energy the electrons have as they move around the nucleus. So the electrons are constantly orbiting, or what we say orbiting means to move in a circular path. They are constantly orbiting, moving around in these shells. Now, something that's really important to understand is that these aren't physical rings. It's not like they're stuck on a track going around the atom. It's just showing the path that they go in. So the electrons go in this circular path around the nucleus. Okay, they're not physically rings and they're not physically there, but we can think of them as being the paths that the electrons are going on. So this one here is the shell that is closest to the nucleus. And we call this the first shell, or the first energy level. So this here is the first shell. Obviously then, the one outside of that, this is going to become called the second shell. So this is the second shell. So the part where the electrons go is called a shell, and the one closest to the nucleus is called the first shell, and the one further away is called the second shell. And yet, if we have more electrons, then we could have a third shell and a fourth shell and a fifth shell. Just depends how many electrons you have. Another really important thing to note is what's in here in this gap where between the electrons. So in the gap between the electrons, sorry, that's not a very neat arrow, that's a bit of a mess. In the gap in between the electrons it's not air, because the particles of air are too big to get in here. So it's not actually air, it's what we call empty space, which means there's absolutely nothing there. It's kind of like space is, it's like a vacuum. So it's empty space. So there's no matter, there's no anything here. It's just empty space. All right, so what I want you guys to do now is, this is what you guys already have, this here. What I want you to do now is add these labels: nucleus, first shell, second shell, and empty space. So I want you to pause the video and add that now, please. Great, you're ready to do some practice. So hopefully you have completed that diagram. So you should only be actually listening now if you've completed that diagram. Let's just check that you have put those things in the right place. You have labeled them correctly. This is what you should have. So pause your video and make any corrections that you need to now. This is the diagram that you should have. Add in any detail that you didn't have already. Okay, so once you have that done, you're ready to do some practice. Let's have a look at these questions. So in your practice copy, I want to start answering these questions for me. A reminder that if you don't do these questions, then you're not going to learn very much. So it's a waste of your time if you're just sitting listening, waiting for me to give you the answers. You have to practice. Practice makes permanent. That's what we're here for. Okay. So I want to pause your video. You will need your periodic table for some of these. Some of these are revision questions from the previous lesson. And number 10 really requires you to have a little think and suggest how different atoms could be different from each other. All right, so pause the video, try these now, please. All right, answers are coming up. Well, first of all, which is smaller, an atom or a proton? Well, a proton is inside the atom, so the proton has to be smaller. Protons are smaller. What is in between the electrons? Empty space. Hopefully that's what you said. Well done if you got that right. And just a quick reminder here that you should actually be physically correcting these or fixing them. A student draws an atom and labels the center nucleus with electrons. Explain why the student's wrong. The student's wrong because there's no electrons in the nucleus. So nucleus does not have any electrons, so you should have that. What label should the student use? The student should say nucleus with protons and neutrons. So great if you spotted that and you were onto that, good stuff. Which element is in group 4, period 5? Well, this is one that you're definitely going to need your periodic table for. So if you didn't realize that now, you need to go and get your periodic table now. Okay, so pause your video and do question 5 if you haven't already. Look for period 4, group 4, period 5. And if you still didn't know, guys, maybe you can't remember what a group and a period are. A group is a vertical column and a period is a horizontal row. So you need to go to the group number 4 and period number 5. Okay, I'm hoping that you said the element was tin and symbol is SN, SN for tin. So well done if you got that right. Is vanadium a metal or a non-metal? Vanadium is a metal. Shells are also called what? Shells are also called energy levels. Well done if you got that. What properties would you expect vanadium to have? Well, that's any of the metal properties because it's a metal. So it's a good conductor of heat or electricity, high melting and boiling point, ductile, malleable, all of those metal properties. A student has a sample of phosphorus. Will it be most similar to nitrogen, silicon, or sulfur? Explain your answer. It would be most similar to nitrogen. So well done if you said nitrogen. And explain why. If you didn't say nitrogen, and I don't think you quite understand, why would elements be similar to each other? So why is phosphorus and nitrogen similar? Well, it's got to do with the group that they're in. So if you didn't answer this right, take another look at the periodic table, and I've given you a clue. You've got to look at the group. Okay, hopefully you realized that nitrogen and phosphorus are in the same group. They're both in group 5, which means that they will be the most similar. Okay, the other ones are not in the same group. They are in different groups, so they will not be more as similar as these two if they're in the same group. Last question. In what way do you think atoms could be different from each other? Well, that's all got to do with the number of protons, neutrons, and electrons that they have. So if they've got different numbers of subatomic particles, protons, neutrons, and electrons, that's going to make them different from each other. So like we said before, an element is a substance made of only one type of atom. And I never really explained to you why are there loads of types of atoms. Well, it's got to do with this. How many of the subatomic particles do they have? That's the key. All right. So I'm just going to put up the written answers. You can pause the video and make any corrections that you need to make. Do that now, please. Okay, we're ready to learn a little bit more. Now we're going to have to make it a little bit more complicated now. Hopefully you've been with me up to now and you're going to stick with me. So we've previously learned about properties of substances. So what was a property? So I want you to speak your answer on 3 to the screen. So when I count to 3, you're going to speak out your answer, please. So 1, 2, 3, what is a property? I'm hoping that you said a property is a feature of a material that you can see or you can measure. Now there is a property, there's this thing called charge, and it's kind of hard to fully explain what charge is. It's quite a complicated thing, but know that charge is a property of small particles. So it's a property that we can measure. Sometimes we can see it in action. Okay, so charge is a property that small particles can have, and it can be positive, negative, or neutral. Those are the 3 possibilities for charge. Okay, so when we talk about charge, we need to talk about the 3 subatomic particles. So if we talk about, say, for example, protons, neutrons, and electrons. So these are our 3 subatomic particles. And when we talk about their charge, we refer to something called the relative charge. Relative charge. And relative just means compared to each other. So if I was to say, if we were to try and measure the charge on a proton, a neutron, or electron, I would be able to find a number, and it would be a really tiny number, and it would have a really strange unit, and it'd be quite complicated to explain it. So I don't really want to talk about charge in terms of its a number, a big long number. We're just going to keep it simple. Compared to each other, what size charges do we have? So we call this the relative charge, and hopefully you'll get the idea in a second when it will be more clear. We say that protons have a positive charge. So protons are positively charged. This is a really important idea, so I really need to pay attention. They have a positive charge. Protons have a positive charge. And the relative charge, we say it's plus because it's positive, and it has a +1 charge. We just give it a number 1. So however big that charge is, we're just going to call that's a 1 charge. The size of a charge on a proton, we're going to say that's 1. Now, relative to that, electrons have a negative charge, so it's completely opposite. So we say negative, but it's the same size. So it's -1. It's -1. So electrons have a charge of -1. It's the exact same charge as protons, as the charge on the proton, but it's completely opposite. It's negative. So protons have a positive charge, electrons have a negative charge, +1 and -1. Neutrons have a neutral charge. Another way of saying this is they don't have any charge. We call it a neutral charge if they don't have any charge. And the relative charge is 0. They just don't have any. So compared to the other two, they have no charge. So neutrons have 0. Protons and neutrons both have a charge which is the same size but opposite. So we call this +1 and -1. So protons are positively charged, neutrons are neutral, and electrons are negatively charged. It's a really important idea that we need to get our heads around right now. Okay. What we're going to do is we're going to put that onto the diagram. Okay, so we're going to put that onto the diagram. So what we're going to do is, now that you can't see the table, I'm going to open up a box here under electrons. I'm going to open up a box under proton. And I'm going to open up a box under neutron. And you should do the same. And in those spaces, I want you to fill in what is the relative charge of the electron, the proton, and the neutron. Maybe do it in pencil, so if you make a mistake, it's easy to fix. So do that now without looking back, without rewinding, please. Okay, so you should only be watching the video. Yeah, so I hope you pause the video. You should only be watching the video now if you have done that. If you haven't done it, pause it now. Okay, and you should be watching and fill this in for me. So electrons, you should have said, have a -1 charge, which is obviously negatively charged. Protons, hopefully you said, have a +1 charge. The relative charge is +1. This is obviously called positive. And neutrons have 0 charge. We call this neutral. They don't have any charge. Okay. Now, if you want to, if you feel like you need to, you can stop and you can take down. Actually, no, I would ask you that table now, if you take that down in your notes as well. So take down the table, protons, neutrons, and electrons, and the relative charge. So pause the video and do that now. Okay, why is charge important? Well, there's a couple of things that happen. There's a couple of what we call rules. And the rules is that when we take these little particles and we put them close together, if we put close together, two oppositely charged atoms, like we have a positive atom and a negative, a positive particle and a negative particle, what's going to happen? Well, when we do this, what we find that happens is that they become, you see these two arrows, show them moving towards each other. So without you pushing them towards each other, they will literally pull closer to each other. We say that they attract. They attract. And the result of this is that at the end, they basically stick together. So they will attract to each other, and they will get pulled closer together. So the rule here is that oppositely, sorry, this keeps auto-correcting. I need to turn that off. Okay, so opposite, sorry, it should be an O, opposite charged objects or particles attract. So that's rule number 1. Rules. Rule number 1 is that oppositely charged objects attract. That's what we've shown there. A second rule is that if we put two charges together that are the same, so say we put two particles together and they're both positive, or we put two particles together that are both negative, what we observe happening in these cases is actually the opposite. They push away from each other. So they don't want to stick together. They push away from each other. And we call this type of reaction, we say that they repel. So we call these similarly charged objects because they are both positives or they are both negatives. We call them similarly charged objects. And what happens? They repel. So similarly charged objects repel. That's another rule. So we have opposite objects attract and similar charges repel. Okay, opposite charges attract, similar charges repel. The last case is where we have a positively charged particle and a neutral particle, or we have a negative particle with a neutral particle, or we have two neutral particles. So the neutral particles are shown with the zeros. Well, in these cases, they don't attract or repel. Nothing happens. They don't interact with each other at all. So that's the third rule, is that neutrally charged objects, they don't attract or repel. So they neither attract or repel. So those are the three rules of charge. Oppositely charged objects attract, similarly charged objects repel, and neutrally charged objects neither attract or repel. So at this stage, wherever you take down your notes, it's probably a good idea to take note of the rules of charge. If the diagrams help you, if they're going to help you to remember, then you can take them down, but it's probably a good idea to take down the three rules. All right, you're ready to do some practice now. So I'm going to move off that screen. So pause the video if you need more time. We're going to do some more practice. And yeah, it's important that you try to do these from memory. So do turn off cover over any of the notes that you've made there. All right, these should be nice, quick, and easy. Pause the video and answer the questions, please. All right, you should only be watching if you've answered the questions. A student puts a positive and a negative charge close together. What happens? Well, they attract. So the first one is they attract. The student puts two positive charges. What happens? Well, they repel. Well done if you said that. Okay, so they attract is number one and they repel is number two. The student puts a neutral charge and a negative charge close together. What would happen? They neither attract or repel. Neither attract or repel. You could just say nothing happens or repel. So these do not interfere or interact with each other at all. A student puts two neutral charges together. What happens? Nothing. They don't attract or repel. A student puts a proton and an electron close together. What happens? Well, a proton is positively charged. So that's the first thing you have to think. I'm just going to underline, well, that's positive. And an electron, well, that's negative. So they're opposites. So what happens? They're going to attract. So they attract. Well done if you said that. A student puts a neutron and an electron close together. What happens? Well, this is neutral and this is negative. Well, so long as I've got a neutral, nothing's going to happen. So the student puts a neutron and an electron close together. What happens? Nothing. And last of all, complete the table, the relative charge. So protons, you should have written, hopefully you wrote +1, electrons, 0. Oh, no, that's incorrect. Hopefully you spotted my mistake, that electrons are -1 and neutrons are 0 or no charge. All right, good job. Well done if you've done that, if you got all that right. We're almost there. We're just going to talk about one more little thing, and that is we are going to talk about the three particles in terms of their mass. And again, like I said, up here, remember when we talked about the mass of this atom of uranium? It's the whole atom is like point, and then you got 26 zeros and then 395 of a kg. That's the whole atom. So what are the protons, electrons, and neutrons going to be? If they're inside the atom, they're even smaller. I don't even want to think about that, to be honest, how many zeros I'd have to put. So there's no point in dealing in a number of kilograms. The numbers are just too small. So again, we use what we call the relative mass. Relative mass. So compared to each other, which one are the biggest? So we let the biggest one, if there's one that's biggest, we'll consider it to have a mass of 1. That's probably the easiest way to go about it. Okay. So instead of dealing in really tiny numbers, we use the relative mass. Now, the relative mass of a proton is 1. So we give it a mass of 1. So compared to that, how big are the others, or how massive are the others? Well, a neutron has exactly the same mass as a proton. So both of these have a mass of 1. Now, electrons are really, 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 really tiny compared to even protons and neutrons. Their mass is 1 over 1836. So it's 1 over 1836 compared to the proton and the neutron. It's a tiny, tiny fraction of the mass of those. If these are about 1, then I have to take that 1 and divide it by 1836 to get the mass of an electron. Because of that, we sometimes say that the mass of an electron is negligible. And negligible means so small that you can almost count it as 0. It's so small that it's pretty much 0, pretty much has no mass. Now that's not technically true. It has a mass of 1 over 1836 compared to the others. That's so tiny that it's not worth even considering. It doesn't really impact the mass of the atom at all. Now, if you think about it, both of these have a mass of 1, and both of these are found together in the nucleus. Protons and the neutrons are found in the nucleus. That means that almost all of the mass of the atom, because remember, the electrons have only this tiny mass, almost all of the mass of the atom is found in the middle. So nearly everything that the atom is made of, all that mass is bang in this tiny, tiny place in the middle. So we say that the mass is concentrated in the middle, in the nucleus. So we say that most of the mass is concentrated in the nucleus, which means this is a really small space, but all of the mass is found here. So most of the mass is concentrated in the middle. The rest of the atom is mostly empty space. There's no mass there. Okay, you just have these electrons whizzing around in these circle paths, and they don't have barely any mass. So nearly all of the mass is in the nucleus, and the rest is electrons whizzing around. They're really, really, really tiny masses. All right, so what I'm going to get you to do, I'm going to get you to pause the video, and I'm going to get you to add the relative masses in. Now, these numbers are important, and we do need to know them. So we need to know the numbers for mass, and we need to know the numbers for charge. They are important. Let's stick them in on the diagram. Okay, so what I want you to do is I want you to put into this box for electron, I want to put in the mass. Into this box for proton, I want you to put in the mass. And into this box for neutron, I want to put in the mass. Hopefully you have some space. Okay, so you're going to put mass equals, and mass equals. Okay, all right, so pause the video and add those boxes into your diagram. All right, this is what you should have. Protons have a mass of 1, good if you said that, and neutrons have a mass of 1. So every proton has a mass of 1. So if you've got 3 protons, then that gives you a mass of 3. And you've got 4 neutrons in this case, that gives you a mass of 4 more. So this atom would have a mass of 7. I'm hoping that you see that because it's got 3 from the protons and it's got 4 from the neutrons. So this atom's mass would be 7. Now remember, this electron really doesn't add to the mass because it's 1 over 1836. So it really doesn't matter. You'd have to have 1836 electrons to even be the same mass as 1 proton. You're just crazy, crazy small. So these don't really affect the mass of the atom. All right. So hopefully you've added that. Now that is the complete diagram, guys, with all the labels. So make sure you have that down. Pause it if you don't and get any extra bits on there. Great, and it's time to answer some questions. All right, so last few little questions here for you guys to do. It's about the masses, most of all. So let's pause the video and answer the questions, please. All right, so you should only listen to my voice if you have done the questions. Red pen or correcting pen now, let's correct them. What is the relative mass of a proton? That would be 1. What is the relative mass of an electron? Well, the electrons are the tiny ones. They have a mass of 1/1836, or could just say negligible. Okay, like I said, you do need to know those numbers. What is the relative charge of an electron? Be careful, okay? So this is where I've got to check. I'm just going to go back and check my answers that I'm going to check the question again. Well, in question 1, it definitely was relative mass. So I did answer the question right. In question 2, it definitely was relative mass. So I did answer the question right. Question 3, though, is relative charge. So I've got to be careful because this is different. Relative charge of an electron. Electrons are negatively charged, -1. What is the central part of an atom called? So the middle is called the nucleus. Well done, if you got that right. Good job. What is another name for an electron shell? Oh, that's a tough one. That will be energy level. So well done if you said that, energy level. Okay. What is the relative mass of the neutron? All right, just double check. It's definitely mass they're asking me about. So the relative mass is 1. Neutrons are 1, same as protons. Where in the atom is most of the mass found? Well, the protons and the neutrons are the things with the mass. The electrons don't really have. And those are found in the nucleus. So in the nucleus is where most of the mass is found. All right, guys, I'm hoping that you found today's video pretty straightforward. It is a tough concept. Some students struggle with this because I think teachers fly through it too quickly. If I have flown through it too quickly, please do leave a comment below and I can maybe break it into, or I can go over it again, go into smaller bits, or you can always go back and just watch it again. Sometimes it just takes that second time of hearing a bit of it to actually make sure that you get it. All right, like I said, this was a really, really important video, a really important idea. And if you don't really get this, then the next video is going to be hard. So make sure you master this content before you go to the next video. All right, so it was nice to have you all join. If you have any comments, do leave them below. If you can leave us a like, it would be great. It helps other students to find the video. And if you need, or if you'd like me to make any particular video about another topic, do leave a comment below and I can get making it. All right, guys, thanks for joining. I'll see you in the next one.